Osmium tetroxide with NMO adds two OH groups syn onto a carbon-carbon double bond. Now, I'm going to show you the abbreviated mechanism for this. What happens in this reaction is have an alkene, and here we have the osmium tetroxide. And first thing is what's called a cycloaddition. Where the electrons from the osmium-oxygen bond go to this carbon. The electrons from the carbon-carbon pi bond go to this oxygen. And the electrons from the osmium double bond oxygen then go on top of the osmium. It's an irreversible process, and all the steps happen at once, meaning there's not any time for this carbon-carbon bond to rotate. You end up getting an oxygen bound to an osmium, double bond to that osmium, double bond there, oxygen here. And this is an osmate ester. Now what happens next is this osmate ester is hydrolyzed. It's hydrolyzed by a small amount of OH minus. This OH minus actually is generated in the full mechanism. The way this OH minus works is it adds to the osmium, and the electrons from the osmium-oxygen double bond go up onto the oxygen. Remember this motif well of an oxygen adding to an atom that's double bond to an oxygen, and the lone pair, the pi bond to that oxygen ends up going onto that oxygen. And this is a reversible process, meaning the electrons can come back down, reform the osmium-oxygen double bond, and kick off the OH, or it can kick off one of these oxygens. Resulting O- can deprotonate water, like so. And this generates another OH-, which can then add to the osmium. Electrons go up onto the oxygen. Like so. And then the electrons come back down. And they kick an OH off. Then you go right back where you started from. Or they can kick this OR group off. And this molecule steals a proton from water. And you end up with your product plus this osmium that's a reduced form of osmium. And this reduced form of osmium reacts with NMO to regenerate the osmium tetroxide, which goes back through, finds another alkene, and does this entire process over again. Also generates a little bit of water, and N-methylmorpholine as a base. And this can deprotonate water, generating a hydroxide, which ends up being fed back into the reaction.